Hey all, hope you're having a great day today. Today we're talking chapter 19, it's part 2, and we're looking at Olympic lifts as well as plyometric and speed and agility today. So here we go. The Olympic lifts, the snatch, clean and jerk, and several variations are total body resistance exercises that recruit most major muscle groups. They are the most complex and resistance exercises to perform and are considered the most effective exercises for increasing total body power. Because of the complexity of these lifts, fitness professionals should have advanced training and instruction before using with clients. Repetitions are performed with fast movements of the lower body and trunk, as the arms serve as guides and assist the client in preparation for catching the bar. And the kinetics closely resemble jumping and several motor skills comprising many anaerobic sports. The clean and jerk is a two-staged exercise where the athlete lifts the bar from the floor to shoulder level and then to an overhead position. Olympic lifts should be performed on a wooden platform with bumper plates. However, some facilities may not have platforms, so modifications can be made to create adequate space, and the use of a matted surface may suffice. It is important to teach the client how to properly drop the weights when learning the Olympic lifts. A missed lift could do more harm to the client if it is continued erroneously. Rather, it is safer to drop the bar in a controlled manner. Lastly, the Olympic lifts are ideally performed using a hook grip. The hook grip involves wrapping the thumb around the bar and then wrapping the first 3 fingers around the thumb and bar for added support. A strong grip is necessary, and this configuration allows for greater support during fast pulling movements. Although effective for grip support, the hook grip is uncomfortable and may take some time for the client to adjust to the technique. The power clean is used to assess maximal strength and power. It results in larger amounts of weights lifted compared to the snatch, which involves lifting the weight directly from the floor to an overhead position. The snatch is considered more complex because the bar must be lifted at a greater distance directly from the floor, requiring greater bar velocity. Variations such as the overhead squat, hang clean snatch, the Romanian deadlift, and high pull are related exercises that enhance specific performance aspects of the complete lift and are used for strength and power enhancement, as several require fast force production and teach proper kinesthetic awareness needed to apply maximal force to the ground. Often these exercises are taught in progression, starting with the clean and later the snatch, as they are similar in movement during some phases. So with the clean, the power clean, the starting position, the second is the pull phase, and the final position after the catch when the client descends with the bar into the full front squat position. The snatch, this is the snatch, so that you can see the starting position with the bar on the floor. Then you have the second pull phase, and then the catch position where the client descends into the full overhead squat position. The Olympic lifts are technically challenging resistance exercises. Discussion of proper technique is best summarized by dissecting the lifts into phases. Because the clean and snatch have some similarities, they will be discussed together, and their differences are highlighted. The phases included the starting position, the first pull, which is where the barbell is pulled from the floor, a transition phase starting to the second pull, then you have the second pull, the catch, and the finish. And here you see this is a sample workout emphasizing the Olympic lifts. And you have the full snatch, which is you're doing about 5 repetitions and 1 to 3 sets at about 75 to 80% of the 1RM, with a 3-minute rest interval in between your repetitions or between your sets. You have the snatch pull. You're doing 5 repetitions at 3 sets and about 85% with, again, the 3-minute interval. And then the overhead squat, you're doing 4 repetitions for 5 sets at 70% of the 1RM. And then the good morning, 3 repetitions for 5 sets at 85%, and the Romanian deadlift with the snatch grip about 3 repetitions, 5 sets, 75 to 80%. And again, you're all resting between about 3 minutes. Plyometric training is a form of explosive exercise that targets power development. Historically, plyometric training was known as shock training and consisted mostly of depth jumps and variations where the intensity was ultra high. But current plyometric training includes lower intensity exercises as well. Plyometric actions encompass the stretch shortening cycle, or SSC, where the lengthening or pre-stretching of skeletal muscles under loading enables a more forceful contraction muscle action. The eccentric phase plus the length of the brief isometric phase between the eccentric and the concentric actions is called the coupling time and is the amortization phase. Minimizing the length of the amortization phase maximizes the use of elastic energy, making for a more powerful effort. Although plyometric exercises are classified based on intensity, which is the impact loading and complexity of the exercise, they are still performed with maximal effort. Plyometric training increases athletic performance such as jump height and power, sprinting ability, agility, and muscle strength. Vertical jump performance may increase an average of 5 to 9%. Plyometric training is most effective when combining with resistance training for increasing performance. For example, plyometric training 2 days per week can easily be integrated with resistance training. Plyometric training can be performed on separate days from weight training or on the same day. If performed on the same day, plyometric training may be given priority and performed first. If only the upper body is resistance trained that day, then lower body plyometrics can be performed uninhibited, and the sequence can vary. It is not recommended that high intensity lower body resistance training and lower body plyometric training be performed on the same day, as the modality trained second would do so in a semi-fatigue state. Plyometric drills can be incorporated into a weight training workout, more complex training. Plyometric exercises such as the vertical jump, standing broad jump, and ball chest pass put can be used for maximal power assessment. The maximal vertical jump performed near a wall or using a vertex is one of the most common power assessments used for athletes. The higher the jump, the greater the power the athlete possesses. The standing broad jump is another example of power assessment, testing power during horizontal locomotion. For upper body power, often with the medicine ball chest pass or put is used. The client is seated or standing with his or her back against a support or wall and chest passes the ball as far as possible. The farther the ball travels, the greater the power output. The fitness professional can easily incorporate these exercises into an assessment battery. Minimal equipment is needed. If the personal trainer does not have a vertex, a tape measure can be used for both vertical and standing broad jump drills. Chalk can be used on the fingertips to mark superior position during the highest segment of the vertical jump. A medicine ball, tape measure, chalk, and a bench with back support for the seated chest pass are needed for the chest pass. Chalk is placed on the ball and the location is marked when the ball lands on the ground. The distance is measured. Standards are available for the fitness professional or the individual can develop their own data for consideration. Plyometric training is safe for clients of all ages provided it's properly supervised. The most common causes of injuries are violation of training guidelines, including an inadequate warm-up, progressing too fast in volume and intensity, poor technique or poor surface selection, and undisclosed predisposition. Progressing too quickly in volume and intensity could result in overreaching and subsequent of overtraining. Overtrained clients are more susceptible to injury. Inadequate warm-ups fail to prepare the client for intense exercise, and poor technique may limit exercise selection as sufficient coordination, balance, and strength are needed for moderate to high-intensity plyometric exercises. And proper landing can place the client at greater risk of injury. And caution must be used with large clients. A prior injury or predisposition to injury can place the athlete at greater risk. Careful monitoring of clients is necessary. An injury may necessitate altering or temporarily discontinuing plyometrics until medical clearance has been obtained. Plyometric training variables include exercise selection, order, intensity, volume, frequency, and rest intervals. Designing a plyometric training program is multifactorial and should include planned progressive overload, specificity, and variation. Many factors need to be considered for plyometric training, including the age and training status of the client, equipment availability, training surface, recovery in between workouts, nutrition, and the integration of plyometrics with other training modalities. Some critical factors include the following, such as quality of training. Each repetition should be performed with maximal effort, minimal amortization, and maximal velocity. With exercise selection, the selection should be as specific to the demands of the sport activity as possible, comprising unilateral and bilateral drills. Plyometric training should take place in an area with sufficient space. For example, horizontal length of at least 30 to 40 yards and ceiling height indoors should be higher than maximal reach. Proper technique should always be instructed. Sufficient rest should be given when peak power is the goal. Gradual progression entails increases in intensity via the addition of complex exercises and some external loading. Low intensity and moderate intensity drills should be mastered before progressing to high intensity drills. Volume can be increased with number of contacts and should be progressed gradually. High intensity workouts require longer recovery periods in between workouts. Plyometric exercises consist of jumps in place, standing jumps, multiple hops and jumps, bounding, box drills, depth jumps, and throws, preferably on grass or a matted surface. The surface should be yielding to reduce joint stress, but not too yielding to limit that SSC, or the stretch shortening contraction activity. Jumps involving maximal vertical or horizontal motion. Hops involving maximizing the repeated motion for a specific distance or pattern. Bounds are exaggerated horizontal drills with excessive stride length. And box drills involve jumping on or off boxes of different sizes. Depth jumps involve accentuating the eccentric component by stepping off of a box prior to performing an explosive jump while spending minimal time on the ground. Intensity increases as drop height increases, and most often drop heights of 20 to 115 centimeters are used, or 20 to 40 centimeters to begin with gradual progression. As the optimal depth jump height is debatable and individualized, tosses and passes involve the upper torso and arms releasing the ball or object below or in front of the head. Throws involve the upper torso and arms release the ball or object above, over, or across the head. Some drills can be combined to form a more complex drill, that is, adding a sprint or multi-directional hop or jump to a depth jump. Ballistic resistance training is a plyometric modality aimed at increasing muscle power and strength. Traditional resistance exercises are performed in a full range of motion where noticeable deceleration of the load occurs prior to completion of the concentric phase. Deceleration is inevitable because the lifting action must then be reversed, lowering the weight prior to lifting the weight for the next repetition. The length of the deceleration phase depends on the weight and velocity, but may comprise more than 50% of the concentric phase when lifting weights lower than 81% of the 1RM. However, this deceleration phase limits power development through the full range of motion. Ballistic resistance training is designed to minimize deceleration by having the client maximally accelerate the bar throughout the full range of motion. Maximal acceleration results in releasing the load or throwing the object or having the client leave the ground, such as jump, during a squat type exercise. Some common ballistic exercises include jump squats, bench press throws, and shoulder press throws. If a linear position transducer is available and attached to the barbell, these exercises may be used to assess peak power in clients. Caution must be used because the external load and participant's body weight must be absorbed prior to the next repetition. In lieu of these safety concerns, equipment has been designed using various braking loads corresponding to 15 to 60% of 1 RM for the jump squat and bench press throw. Although body weight alone may maximize power output during jump squats, personal trainers or fitness professionals may incorporate ballistic training in various ways. It may be integrated into resistance training and or plyometric training workouts. Because of the power component, ballistic exercises are performed in a similar manner to Olympic lifts, in that they receive priority in sequencing. Loading may vary but tends to be moderate to enable fast lifting velocities. Another programming alternative is to use potentiation to enhance ballistic exercise performance. For example, a fitness professional may have the client perform 3 heavy sets of squats, followed by 3 sets of jump squats. The heavy squats can facilitate recruitment of fast twitch motor units so that in the absence of fatigue, the jump squats could be performed with greater power output. In addition to power development, ballistic resistance training can increase maximal strength and augment maximal strength development for some exercises. Speed and agility are essential athletic components. Speed is the change in distance over time. So maximal speed attainment takes about 20 to 40 meters. So acceleration ability or ability to increase velocity is a critical training component, especially following a change of direction, deceleration, or from a static position. Sprints of at least 60 to 80 meters involve acceleration, maximum speed maintenance, and speed endurance or deceleration. Acceleration is related to the ability to react to a stimulus with a quick first response. Obtaining and maintaining maximal speeds are functions of conditioning. Agility comprises the ability to move rapidly while changing direction in response to a stimulus. Agility is complex and requires the optimal integration of several physiological systems and fitness components. The client must coordinate several movements, including the ability to react and start quickly, accelerate, decelerate, move in the proper direction, and maintain the ability to change direction as rapidly as possible while maintaining balance and postural control. The rapid change of direction occurs in a variety of stable or unstable positions, such as standing in either a unilateral or bilateral stance, lying, so they could be prone or supine. They could also be seated and or in a kneeling position. Sprint speed is the product of stride length and frequency or rate, how many times you turn your legs over. Stride length is determined by leg length, leg strength, and power and sprinting mechanics. Stride frequency refers to the number of foot contacts per period of time. And maximal sprint speed occurs only at the optimal combination of stride length and frequency. Sprint, plyometric, strength, and ballistic training are the most effective ways to increase stride rate and frequency. An integrated approach is most effective where a combination of plyometric, sprint, flexibility, and resistance training is used. Sprint training increases acceleration and sprint speed, and the combination of sprint and resistance training enhances maximal speed, speed endurance, power, and strength of the lower body. Agility requires mobility, coordination, balance, power, the stretch shortening cycle, efficiency, stabilization, proper technique, strength, flexibility, body control, footwork, and rapid ability to accelerate and decelerate, as well as anticipation and scanning ability. Agility training includes multiple modalities, including strength and power, sprint, specific agility, balance and coordination, and flexibility training. Exceptional balance is needed to control the center of gravity. Stability is greatest when the center of gravity is low, the base support is large, and the line of gravity is centered within the base support. Force production is greatest in stable body positions. Performing an exercise unilaterally instead of bilaterally, narrowing the base support, and performing an exercise on a stability ball or BOSU ball or balance disc, a beam, or wall board may improve balance. Performing an exercise with one's eyes closed, a combination exercise, or an exercise from an unstable position, such as performing a shoulder press from a lunge position. In addition to sprint, plyometric, and agility drills are all ways to improve balance. Proper posture, foot contact with the ground, and arm action are needed during agility movements. Agility drills involve multiple movements, including linear sprints, backpedaling, side shuffling, drop stepping, cariokas, cutting, pivoting jumps, and crossovers. Sprint and agility training consists of drills aimed at targeting linear speed and multi-capacity movement development. Fitness professionals should constantly monitor correct sprinting technique and be instructional to clients during agility drills. Clients should touch or run around cones in control, staying close to the cones, have correct foot placement, and lower their center of gravity. Decelerate and accelerate maximally and have correct posture and approach angles. Cone angles and the number of cones modulate the level of changing direction and pattern of acceleration or deceleration. Close distances force the client to change direction rapidly without large windows of acceleration, whereas large distances enable the client to accelerate over greater lengths, which also creates an opportunity for deceleration management upon changing direction. Drills may be integrated to increase complexity. Agility training can be performed with zero, aligned field, or minimal equipment. The fitness professional can expand the client's exercise repertoire by having cones of various sizes, agility ladders, rings, and agility dots, reaction balls, bags, tires, mini hurdles, reaction belts, ropes, and or agility poles. Speed and agility drills include the following, like form drills. These are drills that are used to improve technique and serve as general warm-up or dynamic range of motion exercises such as arm swings, butt kickers, high knees, ankling, marching, and pawing. Drills are usually performed for 1 to 3 sets for 20 to 30 yards. Linear sprints are sprints of various lengths. They can be short sprints of about 10 to 20 yards, which are used for improving acceleration. Moderate sprints of about 40 to 60 yards are used for improving acceleration and maximal speed, whereas longer sprints of about or greater than 60 yards are used for improving all facets of sprinting, especially speed endurance. These sprints are performed with maximal effort. Other variations may be used. For example, a drill called gears can be used. The client may sprint for 100 yards. Cones could be set for every 25 yards. The client runs around 50% the first 25 yards, accelerates and runs faster upon reaching the second and third 25-yard markers, and will sprint maximally the last 25 yards. This helps improve acceleration ability from a running start and maximal speed. The drill falling starts can be used to improve acceleration from an unstable position. The client leans forward and falls forward, or can be pushed by a partner, braces, and subsequently sprints forward for the desired distance. Linear sprint drills are the most specific way to increase sprint speed. Overspeed training allows the client to attain supramaximal speed by increasing stride length and frequency, or an assisted speed that is greater than maximal effort. Supramaximal speed can be achieved with a tailwind, downhill running of around 1 to 7 degrees for around 50 meters, towing, and high-speed treadmill running. The supramaximal velocity attained should not exceed a value of greater than 10% than the client's own ability, or technical breakdowns could occur. Overspeed training is most effective when performed early in the workout, where the client's energy levels are high and fatigue is minimal. For towing, elastic tubing such as bungee cord and latex tubing can be used and attached around the client's waist. The opposite end can be used to attached to another athlete or a stationary object. The force of the tubing from stretching propels the client forward, thereby allowing the client to increase stride length and frequency. If a stationary object is used, the client can attach the tubing in front, back up several yards, and begin running while being towed by the elastic tubing. The farther the distance, the greater the stretching of the tubing, as more force will be applied to the client. The client may connect the other end of the tubing to another client or the fitness professional, and the client can attach the tubing in front, while the other client doing the towing can attach the other end of the tubing to their rear. The lead client begins sprinting and towing the rear client. Towing can be used for other drills such as backpedaling and side-to-side movements as well. In resisted sprint training, the client sprints maximally against a resistance. Resistance may come in the form of headwind, sleds, speed chute, sand, weighted vests, harnessed a partner, stairs, and hills. Sleds are made of steel, have a handle and a harness attachment, and have posts for plate loading. Loads of up to around 10% of the body mass for sprints of about 10 to 50 yards are typically used for speed training. A speed chute opens, thereby increasing resistance as the client accelerates. And chutes come in different sizes and provide various levels of resistance, especially at higher speeds of motion. Weighted vests are light, durable, and have the capacity for external loading, perhaps up to 10 to 20 pounds more. They are multi-purpose and can be used for plyometric, agility, calisthenics, body weight, and sport-specific exercises. A harness can be used between two clients where the trailing client can provide resistance to the lead client. Enough resistance should be applied to allow the lead client to sprint to around 85 to 90% of max speed. Some harnesses have a quick release mechanism which allows the cord to disengage, enabling the lead client to continue sprinting without resistance. These can be used for other modalities besides linear sprinting, for example, backpedaling or lateral movements. With programmed agility drills, these are pre-planned where the client is aware of the movements prior to beginning the drill. Some examples include the T drill or the square drill, the 20-yard shuttle, figure 8 drills, and right triangle drills. There are numerous programmed drills that can be prescribed to a client. Drills should encompass the basic movements of linear sprints, accelerations and decelerations, backpedaling, side and diagonal shuffling, cariokas, cutting, and pivoting. The reactive agility drills are continued based on information from a fitness professional or object, such as a ball. The client must react to a stimulus. Some examples include the box jump with multi-directional sprint, partner shadow or mirror drills, slap or tag drills, and drills that involve ball tosses and catching, such as the blind partner toss. With quickness agility drills, these are designed to produce fast movements and quick feet. Some examples include agility ladder drills, pop-up drills from the ground, down and up drills, such as sprawling and wrestling or the burpee, and the resisted let go. Numerous ladder drills can be prescribed to the client. Some common ladder drills include ins and outs, hopscotch, two and lateral shuffle, and the side rocker. Novice sprint and agility programs should focus on proper technique and footwork using basic drills. Basic drills have low levels of footwork complexity and change of directions. Complexity increases intensity. High-intensity agility drills include those with complex movement patterns, multiple directions, involve high rates of acceleration and deceleration, are reactive, and may incorporate some moderate to high plyometric drills, in addition to basic agility movements. Similar to other modalities of training, variation of volume and intensity of speed and agility is more conducive to progression rather than just increasing over time. In this next example, you'll see it depicts a sample of combined sprint and agility workout that is an integrated approach where both components are trained in a single workout. It is important to note that the fitness professional can prescribe and supervise independent sprint and agility workouts. In this case, the format may be similar, except each workout comprises all speed or agility drills only. Anaerobic conditioning is a term that refers to high-intensity muscle endurance capacity. It comprises the ability to perform near maximal to maximal exercise for an extended period of time. Anaerobic conditioning consists of exercises targeting speed, power, and strength endurance. Speed and agility endurance enhancement enables the client to maintain maximal speed and agility performance over time. Speed endurance training is characterized by longer sprints of around 30 to 300 yards for running and swimming, but possibly longer distances for cycling, and reduced rest intervals in between sets and repetitions of exercise ranging from 75 to 100% of maximal speed. Drills consist of repeated sprints, interval sprints, and relays. Interval training allows the client to train at higher intensities while improving anaerobic and aerobic capacities. Low-intensity bouts of exercise interspersed in between high-intensity bouts allow the client to achieve higher net workout intensity. Intervals using a 1-to-1 ratio target aerobic capacity, whereas greater work-to-relief ratios of 1-to-5 or 1-to-10 target anaerobic conditioning, in particular the ATP, PC, and glycolysis energy systems that we covered in Chapter 5. Agility and plyometric drills can be used in standard set format of high repetitions and moderate set durations with rest intervals, or in circuit training format. For example, endurance training involves low to moderate intensity drills for moderate distances of about 8 to 20 repetitions have been recommended for advanced clients and 5 to 12 for novice clients. For speed endurance training involving high-intensity drills for short to moderate distances, 4 to 12 repetitions have been recommended for advanced clients and 4 to 8 for novice clients. Anaerobic conditioning can also be performed by inclusion of weight training, body weight, or implement training. Circuits allow the client to perform several exercises in a short period of time, yielding substantial metabolic and cardiovascular responses that could improve aerobic capacity as well. Circuit progression entails increasing the load, repetitions, duration, or length of drill, and reducing the total time needed to complete the entire circuit, time circuits. These time circuits are beneficial because they can enhance the power component. Fatigue results in slower repetitions and performance. Thus, a reduced time to complete a circuit indicates improved endurance, as the client can maintain a better pace and movement velocity. Metabolic circuits have become popular among athletes and fitness enthusiasts to improve muscular endurance, aerobic capacity, and reduce percentage of body fat. Anaerobic capacity can be assessed in many ways. Two common assessments include the 300-yard shuttle and the line drill. The 300-yard shuttle requires two parallel lines 25 yards apart. The client sprints as fast as possible from one line to the other line and immediately sprints back to the starting line for 6 continuous round trips. For the line drill, a basketball court is typically used. The client begins at the baseline, sprints to the foul line and back, sprints from the baseline to the half-court line and back, sprints from the baseline to the far foul line and back, and sprints from the baseline to the far baseline and back continuously. Multiple trials can be given for each test, and the best time or average of each test can be recorded. These are fatiguing tests, so plenty of rest of at least 3 to 4 minutes should be given in between trials. Anaerobic capacity can be assessed in many ways. The two common ways include the 300-yard shuttle and the line drill. The 300-yard shuttle, I believe we talked about that. Yep. And that concludes our discussion today. I hope you have a great day and look forward to talking with you again.